Hey, for the work on the last few weeks, I've been doing they're fairly minor things, but then one major thing which took up most of the time. But the minor things is about getting the bullet position in from the tip of the gun, firing from that, and then fixes to the gun position, some extra effects. But the major work the last few weeks has been with the save state. So to get the world and all the objects in the level and your inventory and everything saved when you click save or transition a level, then you have to build a new kind of save manager. Well, change the existing one to be more scalable and with better ways to do it. So that's what I've been working on, and that's what I'll go into for this video. So to talk about now the bullet's position, so when you fire it to make it look like it's coming from the correct position, I've added this gun offset, and that's this vector at the start there, the 0, 0.05, 1.7, and that's say for this gun, but it's a offset vector that starts the bullet in a different position from where the gun's position is. So in the case of this one, it's this vector here that's the difference between the gun's position and the tip of the gun. So this is how I'm adding it here, and this is the rotation matrix. I forgot why I took this screenshot, but I took it, so I'm showing it off here. This is how I handle my camera rotation. So just to show that one. So this section here is when you pick up a gun. Now, as you saw in that first section of code, we have a static vector. Now that vector is only appropriate if you're, say, looking directly down the z-axis. So if you pick up the gun while you're looking in a different angle, obviously the vector of the start of the bullet, where it needs to start, would be different. So that's this transformed offset here. What I'm doing is just transforming, so it's gun dimensions. I initially have named it gun dimensions, but that's, yeah, where you see gun dimensions, that's just the offset I'm talking about. So in the part there, transformed offset, and then you see gun dimensions. Yeah, that's the bullet offset, where I want the start of the bullet to be. It's not really gun dimensions. When I first started working on it, I thought I was going to use the gun dimensions completely, but yeah, I'm not at all, so I just haven't renamed it. So that's the offset, and then we just transform that vector to become a new vector based on your rotation that's relevant to your rotation, and then we set your gun holding offset to be that new transformed amount. So let's say it starts that what you saw with the Z 1.7. If you're looking directly down the X axis, then that might be X 1.7 instead, or yeah, whatever's relevant to the direction you're looking as you picked up the weapon. So that's this part here. And then, yeah, you'll see rotation matrix gets updated from based on create from your pitch roll. So that's this. It's to make sure your gun holding offset is always relevant to the direction you're aiming. So this next part is the bullet. So this is how the bullet gets added by using that offset. So here, this is where I'm adding a bullet, and then the bullet. So from the last video, I think I showed this section, but I've added a bit more. So as you see there, the gun holding offset, and then, yeah, we've got cam target minus cam position, gun holding position divided by the player aim distance, minus also the gun holding offset. Yeah, that's the new change with the offset. So that's to make sure the bullet always starts with the correct offset based on your rotation. Now this chunk of code here, this is updated every time you yaw the camera. So here we are doing a vector transform on your cam target based on your yaw amount, but also that gun holding position gets updated, and then also the gun holding offset is updated. So all those three things are updated. So this is, let's say, if you're holding a gun already and looking left and right, then yeah, we want to always update that vector as well. So the gun holding offset. So all the previous ones, let's say a one-off thing when you pick up the gun, or yeah, this one's auto updated because yeah, cam target is always getting updated on that's that yaw amount. So yeah, if you look to the left, the yaw amount updates, look to the right, and so on. So that's this here. And then this is for the pitching of the camera. This gets updated when you look up and down, similar to the yaw. So yeah, obviously you transform the vector similar. So here, the gun holding position and offset also get updated. And that's it for the bullet position fix. So with all that now, wherever you look, whether you pick up the gun, even on save and load, it should be in the correct position, the bullet, because we have the position we want with the offset of the bullet to start in, relevant to the gun's position. Originally, we're updating the gun's position based on yaw and pitch, and now we're doing the same to the offset, so that vector is always relevant. And another thing I worked on was this gun intersecting with the wall. So some extra stuff I'll talk about with this is always drawing the gun above all the other models. So it always, because before in the other videos, you'll see the gun goes through the models and it didn't look right. And that's why I initially added this kind of gun look up or hold the gun up effect when you're close to a wall. But then, yeah, fixing that now to always draw the gun model above all, so you don't get that gun passing through the other models. That was that part. And then, yeah, also when you're close, it flicks the gun up. That's basically it for that which I've added to fix the gun. So with all these next videos, I'm going to briefly just talk about them and then show the video, because I'll talk about it more in detail in the code anyway. So for this next one, that's the world items. Now, what you should see with this one is the objects in the world, their positions or whether they exist or not in the world is now saved. And so if you load, save and then load, you should see those items positions where they should have been, and then the same in the level transition. And then this next video is for the collidable world items. So that's the crates, seeing all those positions remain if they're destroyed as well. And then, yeah, there's a few extra finicky stuff with them, like whether they stay hovering. So with this, it involved changing some of the logic of the collidable world items collision a bit. But yeah, in this video it shows it. And then this next one is for the entities. So the extra thing with the entities is whether they're alive or dead. There's some model states as well that gets saved. It's not being used yet for the entity besides it being alive or dead, but yeah, for in the future they will have different things, so that gets saved as well. And then this last section is the world objects. So this is all the walls, doors, and everything. This was the largest part of code that needs to be changed. But yeah, this is now saving all the states of the world only where necessary. All right, so now for the code of the new save. So with the stuff I've been working on with the world objects, the entities, the inventory, this has taken a big chunk of my time in the past few weeks, but I needed to do it. Like if I show you this is how I was, and I'm still doing it for the ini. So this is how I was doing it, like just adding to a string. I'm gonna change this eventually, but I'm leaving this part here for now, how it saves the ini. This is where your keybinds are set, and then when you load it, checks if each one's loaded. If it hasn't, it reverts it to a default. So it's kind of like all this heap of code. Now with all the save states and everything, there's so much data, this isn't really viable. Like to manually tell the code, all right, we're adding, and then, looking for each specific one it's not really scalable at all. So now what I've been doing is probably more in line with how most games do it anyway. But yeah, XML serialization, I've always avoided doing things like this, but in the case of this, it's pretty useful. Like, uh, I remember when I was first trying to learn Monogame and looking at the X and A tutorials, they were loading the content, the MGCB from XML serialization, and I really didn't like it. Like the way I still do it is through the content here, just, as you would add to here and then refer to them. And I don't mind this at all. I know there's a lot of talk about it, I've seen, but I don't mind it. So that's, yeah. So anyway, going off topic, now with the new save data stuff, I'm doing it all through serializable. So this is the overall structure of the save game file. Now we have the core stuff, like the specific stuff, like your position, rotation, crouching. Yeah, I added that specifically because if you save while crouching versus not, it's a bit different. Cam rotation, the gun holding positions, the offset, and the current level you're in, and then your mods, they're all stored at that base level there. And then I've got a list of inventory items. So these are the items that are in your inventory, and then a list of levels is the level serialized data, and that has its own list of other things. So we have a list of world items. These are the items that you can pick up from the world, like the guns or the cans or the mods, and add them to your inventory. And then you've got collidable world items. So these are the crates, that you can destroy. But in the case that I've set up, both of these are world items. So yeah, whether they're this one or this one, they're still of the world item class, and I've just handled it. Yeah, so like if it's a pick-upable item, I've overloaded the constructor there. So like, yeah, if it's pick-upable item, just create a new world item object like that. So pick up interactable type, and then verse the collidable world items, movable. And then there's certain differences, but it's all handled in the same class. And then in the save manager, I've got them a bit separate, because if we look at world item serialize here versus collidable world item, for the pick-upable items, we just store this world item ID that I've added. And yeah, I'll go through this in a bit, but yeah, we've got world item ID, the position of that object, and if it's a gun, the current ammo. So yeah, null if it's not a gun, which is why I've got a nullable type there. And then for the collidables, we don't obviously need ammo. It's just for now, the only real thing of these is the crates. So we also store item ID and then health, which the pick-upable items don't have, but yeah, the position as well. So that's those two. And then we have entities. At the moment, it's only the rats, but we have entity ID, its health, position, and model state value as well. So this one is if it's either dead or scared or running away, things like that. And I've got it as a string here because I was having trouble with the way I've set up model state. So I had this as model state, this is all my model state is. It's just like, yeah, I was trying to, it's like an enum basically, but I've just tried to stringify it a bit, because yeah, from what I don't know, there's probably a really elegant way in C# anyway, but I don't know of it, to stringify the enum like this. So instead of, yeah, because I use this to display on screen when you're looking at the object as well. So in this, you see world items, like the doors, can have model state, whether they're closed, open, or entities if they're neutral, hostile, friendly, dead. So that's that part there. So that's all this. And then, so that's those three. And then we have static world objects, which are with this one, these are the things like the doors, the walls, any destructible items except, yeah, so even though I've got these collidable world items, like the crates as world items, I have just these ones as models. So it's kind of a mess how I've set it up, but it works. So yeah, it's kind of separate. So these static world objects are things like the walls, the doors, floors, anything really. And then for that, I'm storing a world ID, the health, and model state value which is similar to the entities. The difference with these, so with inventory items, collidables, the entities, and yeah, the world items even, we have these IDs which define the type of object it is. So if we look at the entity one, and the others work the same way, but here I've got an entity ID, and that just defines the type of object it is. So here, entity ID is rat neutral 1. So any new object I define with that entity ID is going to be of this, it's going to be a rat. And here in that we set everything we need, like my model class, say, I set sprite plane, which is that screen that's always facing you, the texture, everything like that makes it a rat, the death stuff, and so on. And then world items work the same, but for the static world objects, the world ID is separate for every single object. So it works as you would expect the database to handle it. You've got, let's say we have 10 walls, all of the same type. They're exactly the same, but if they're the first 10, say, in the level, they'll get world ID 1, 2, 3, 4, and so on. So it's done this way because for this, I wanted specifically to know which objects are maybe missing health, or if the door state's updated, so that when I load the game, those specific objects are updated. And that's because as well here, I'm handling the loading of objects in two ways. The first way is those static world objects, which is, say, this all models list of models, and then also the interactable models. So there's two lists here in the level. All models has the things like the door, the walls, the floors. Interactable models have the doors. At the moment, yeah, it's only the doors. So this is the first way I'm handling it, is when you load into the level, it still loads all these objects as it would on first load, and then it goes through your load data and updates those world objects. So it iterates through the save file, gets the world IDs and looks for them through these lists and then updates them. So if, say, world ID 6 has, instead of 100 health, it's got 50 health. So then it first loads it at 100 health and then reads the load file, says, all right, world ID 6 has 50 health. It updates the health to that value instead. So that's the first way I've handled the load data for them. And then the second way is for the world items. Then here, what I'm doing is, if it's a fresh load, so a brand new game, then it runs all this. It loads these items, adds all these collidable items to the crates, adds the guns, the mods, everything. Or if it's found data in the save file, then it doesn't load all this, and it just loads this data from the save file. So if I switch to the save file quickly, in world items. So let's say we load the game with this file and we're on this level physics test. instead of loading all these items and collidables, it goes through this data, and so this one here is the world item ID. It then creates a new world item at this position and then sets whatever values you need it to. So at the moment it's pretty simple, like there's either cans, mods, or guns. If it's a gun, it has ammo. So this may be you've fired a few rounds and then dropped it. So instead of 30, this will be 15. So then when you load the game, it creates a new gun and then places it in the world with the ammo that it had set here. So this is the other way I'm loading the data as well. So on one side, we have this preload of brand new objects and then updating those objects. And then on the other side, it's either, load or don't load the objects from code itself. So yeah, it's handled two ways at the moment. So because of that, with the static world objects, I've got this world ID to update each model where it's relevant. So that's the two sections here, why they're handled a bit differently. And then the last thing is the destroyed static world objects. So with the static world objects, it's all good and well so let's say you're playing the level and you destroyed a wall. So the way I've handled it in the game, it removes from this all models list if you destroy the wall. So then, you've got 10 walls, you destroy wall 6. That has a world ID of 7, let's say. So what happens is when you go to save, there's no more wall with ID 7 for it to save in the save file. So without that section that I've added here, destroyed static world objects, then it updates the ones that are damaged, but it doesn't update the ones that are destroyed because they no longer exist when you saved the game. So instead I've added this, and then if the wall gets destroyed, then you add it to this destroyed static world object ID list. So here it's a list of destroyed objects. So then that works the same. If the wall's destroyed, when you load the game, it updates that wall that it first loads when you boot up that level. And then let's say it's this one that's destroyed, it first loads it, and then you get the data from the save file that wall's been destroyed, so it removes it, and then you can start the game. So yeah, that's the two ways I've handled the save data. So now having a look at the functionality that makes use of the serializable data classes there. You have the save game, and this can be triggered in multiple areas. So if we find all references, this could be in interaction. So this one here, the save game gets triggered when you're transitioning from one level to another. So say you're on the level physics test and then you open a door to go to the next area. It saves the game before you change the current level, and then saves again. And this part here is the only difference. This B, if we look here, that's this B from transition. So with that, I'm saying B from transition is false. So it saves this once, and then I change level, and then it saves again, but not with this section. Don't ask me why. Half the time I'm doing things, it's mostly because of spaghetti, but it works, and I'm trying to improve in a lot of areas like this. Yeah, like before being the the strings updating and then saving that way, now at least doing through serializable data. So improving over time, but yeah, it's just how it is at the moment. So always with these videos anyway, I never try and claim this is good ways to do things. I'm just trying to demo the way I've gone about it, and yeah, had fun going about it anyway, because it's mostly self discovery. So yeah, like when the save game here, we could save during transition, or if you quit to main menu or quit the game, it triggers an autosave, or if you manually save. So there's some of the areas that trigger this method here. And then you'll have here just sets your current data to the serializable data. And then, your inventory state, it goes and saves the list there of inventory items. Then so this is, if it's not, there's only that one section that has this to true, this part here. B is from transition. So in most cases, this part gets saved. So what happens with this is this saves your other levels. So let's say you're on level physics test and you've visited 3 other levels. When you visit them, that gets added to your other levels list. And then, well, it's this one, this temp level object store. This is just how I've basically done it. So I don't have to save all the data. It's just only saving the visited levels. So if it's not from the transition state, then you'll have your current level that you're on, all that level's data. You'll have the other levels that you've visited, all those levels data you want to save. So this is the section here. This is for the other levels you visited that you're not currently in. And then we save all that data. So like your world items that's in that level. If there's collidable items, there's entities and static world objects and the destroyed objects. And then, so with that, it tries to save that data. And then we've got this section here, which is if the level already is in the save file, then we update it. That's just, yeah, if it finds it, just update it. Otherwise, we just add it to the list. And then, so these are for all the other levels you visited. And then we do the same for the current level you're in. So you save your current level ID. Then each world item, the collidables, the entities, and yeah, static world objects. So the same thing basically, but for your current level. And then again, checks for that and saves. And then at the end, we're just saving that data through the serialize. So that's the save, how it gets, and that makes something like this. So it's just XML data, as you see, but it's cleaner than having the strings. And I'm keeping it probably XML in this way. I know you can save as the the bit or whatever it is. I've forgotten the name, but as raw data itself, not with any sort of structure. And I know that's probably what most games do, but I'm just keeping it like this. And the final game won't have it like this because I know that's, you can just come to the same save file and update whatever the heck you want. So yeah, I'm doing the same as what I would have done with the strings and stuff, and just encrypting the data. So yeah, this will be added at the end, or set at the end, but instead of putting the save file as readable, this data will be encrypted, and then when you load it, it gets decrypted. So yeah, it's just that to prevent that easy modifiable file. And I know the best way is to handle it as bit file stuff, but yeah, I'm just not doing it because this is easy for testing. I can see when I'm adding it, what I'm doing and everything. So that's the save, and that's how it will look in the save file. And then the only extra thing then is the load game. So to load the data, we just grab it, and then yeah, doing specific things again because the data's handled a bit differently. So with the world items, which either they get loaded from this section, or if they're world items, collidables, or entities, then it doesn't load them from initial load. It instead creates the objects in here. So based on what's in your save data, then we create. So here we got world item, we're creating new world item. And this is another thing. I've built this string converter to just make it a bit easier for the reusable code there. So if it from a string to a world object, and then the world items have guns, and again convert to collidable world items or convert to entities, and then here convert to mod and level IDs as well. So it's just a string converter class handler there. So then that's this section here. It goes through the XML and finds the world item based on the world item ID. Let's say if it finds gun 762, this one, I just saw it, where was it? Here. So if it reads this whole thing, so it reads this, it reads gun 762, it then converts to world item with this world item ID, which then says, all right, we're checking through the list of all world items, world item ID. If it matches, then we create a new world item, this temp item. This is to ensure it's fresh instance for each one of the same object it tries to load. And then, so all world items, world item. If we look at that, that's just every object. So here we've got every world type of world item gets added to this. So it just goes through that list and compares. When it finds a match, then instead of creating a new, it just creates a new instance of that world item. And then, it does everything it needs to, adds world item at grid position. And then if this is for your inventory, so it adds it if you've got it in the HUD slot, sets if these are all other things I've added. If it's a gun, we set the current ammo to this item, which is the serializable version, that current ammo, this part, and then sets the ammo to that, and then updates any strings there. And then so that's the inventory. Then we have, it's pretty much the same principle for the world items for in the world that's not in your inventory, except it just adds it to the world instead of in your inventory, so there's less stuff. And then it adds it to the grid. So the grid is basically the collision grid. I'm just using a grid because I got Octree kind of working, and then it wasn't that good the way I did it anyway. I think I did it wrong, so I'm just using a grid instead of Octree. That's to make the collidables code less resource intensive. And then the collidables we do the same, and then entities also the same. And then the static world objects is a bit different. Like I was explaining before, we just load the values to override So with these ones, it expects the world item or the world object to already exist because it should have been loaded in this part here. The downside with this is if on release, if people have saved games and then for some reason I decide to add or change this list of items, it will break the save games, and I don't like that, but it's pretty much how it is at the moment. So yeah, it just goes through and updates. If the world IDs match, then we set the health and HUD. So like if we look at the file again, we come to static world objects. You see here, this is the number of objects. So basically, yeah, there's 2,500 plus objects, but I'm not saving them all. I'm only saving the ones that, yeah, either have health set or model state value set. So like here they have health set, or here they have model state value set, which is the door. And then we're saving the data for that. So when we load a game, it then generates all these objects again, sets the world IDs, then loads the data, finds the ones that have a match, and then we set the health and the model state value where it's matched. And then same for interactables. And then if it's a door state that's updated, we trigger the door open here. And it was the same with entities. If the health was 0, we set the death in here instead of letting it auto handle. But yeah, with things like the health, we let it update with the game logic anyway. And then yeah, for the destroyed static objects, we find where the world IDs match again, and we set it to 0. And yeah, with this one, we let the game logic handle it. Well, for my case anyway, because when an object gets destroyed in the game, I'm removing it from the all models list that I've been showing, but also there's a separate object that gets added to the grid, and that is destroyed as well. Now, yeah, but then I have to say quickly, because that was a bad thing to have two different models, but the model here, it doesn't get added to the grid. It just is based on its grid position, because to constantly keep adding and removing models from the grid is too much. It takes too much resources. And then yeah, then we just update the HUD, and that's it. So that handled everything in the game so far. But yeah, it's taken a long time to get it to this state. So the other part is now to update the ini to that new way. But yeah, that's basically the save manager now that I'm using. And I kind of talked about this for a bit, but it's been the biggest part of the work this past few weeks anyway. So yeah, and I was kind of wanting to avoid this style again, but it's the best way to show and talk about the code anyway, even though I know I go on about it for too long, which was part of the reason I went to the other style of recording. But yeah, that's it for the save manager stuff for now. So another thing I worked on is just this kickback effect. It's just like the recoil. So the recoil was the flick up, and then the kickback of the gun is when you fire, it just moves backward a bit. So just an extra added effect there. And another minor thing was the gun FOV, so or any holding item, when you change the FOV, the position of that holding item shouldn't change. And that's to fix, like when you switch the FOV, you can see the whole gun if you set the FOV high, or you can't see the gun if you set it to low. So yeah, it gives that holding item its own FOV, which is always 90. And the problem with this is, so as I'm showing in the video, the bullets fired position is based on the gun model, and the gun model changes with the world FOV. So the position that the bullet is going to be firing from is like if the gun model was getting the FOV changes. So it's a small thing, but you know, it's okay for now anyway. So now with the save manager and all that done, that leads on to the next step, which is another big thing that I want to implement. So the next thing I want to work on is the level editor. So currently, to make the levels, I've been just in code trying to figure out the vector 3 for the position that one wall should be in, and then where that wall ends based on its rotation and all that, and even tried to make a prefab class to handle that. And that was early on, and it's not a really easy way to get the level objects in. So the next step is to make a level editor where it'll be just like the player's perspective, and then you can drag objects into the world and place them. Now, with that, they'll make use of the save manager stuff, because for all objects, I'll want to get the positions and save them. So in the level editor, you'll be like placing a wall in the world, and then when you save that data, it saves to an XML file, the same as the save manager class and all that. But the difference will be that that's the level itself. So however those objects get placed, that level gets loaded based on that file. So yeah, that's going to be the next big thing. And once that level manager, well, level creator stuff's in, then I can start creating the levels, and then that, yeah, I can add more models and everything, and just iterate through the list of all models, and then yeah, it'll be a lot more visual to create the levels. So that's what's planned next. And that's it for this video. So I'm not sure when the next video will be, because the level editor stuff is going to be a pretty big thing, even bigger than the save manager stuff. So yeah, it may take a decent amount of time, but yeah, hopefully with the next video I'll be able to show some pretty cool stuff with the level editor, but we'll see. So thanks for watching.